Hello, everybody, and welcome to Data Engineering Stuff. Today, we're going to talk about how labeling bad data can help data quality. So, what's the idea behind bad data labeling? A colleague of mine had the idea in a project to do the following. So, imagine you have a data store and a data consumer. The data consumer does a regular select or whatever technique used to retrieve data, and he retrieves trip statistics for cars, and he gets the average speed of 50 and a total distance of 0, and an average speed of 75 and a total distance of 150. So if you think about that for a moment, you see that the average speed of 50 and a total distance of 0 can't be a real value, because if you have been driving for like 50 kilometers an hour, for example, even 1 minute or 1 hour, the distance must be greater than 0. The second data entry could be correct, because average speed of perhaps 75 kilometers per hour and the total distance of 150 kilometers could be a 2-hour drive. So what was built in the project was a really interesting idea. The data consumers, in this case, this were data scientists, had the possibility to do an API call to label each data entry with true or false. So they could say, this is bad data. We want to label it as true bad data. Okay, we could revert that to say true to good data and false for bad data, but basically they can set a flag on each entry. So with the next select, they won't get this entry back again. So in my opinion, this is a really good idea, because what does that help with? First of all, the next data scientist working on the project would automatically get only the data that makes sense in the real world. So you wouldn't get any broken data. What else are advantages of that? You basically get a feedback loop. So there's not the data engineer putting together data and giving that to the data scientist to be used. He gets feedback from the data scientist about which data is wrong. So what could he do? He could inspect the data, search for patterns, search for reasons why that data is broken, and he can therefore apply new data quality rules to his data pipelines. He could also fix errors in the data pipelines, and he gets metrics for that. Because he has the labeled data, he gets the labeled data back. He always knows, okay, we are getting better. We get only 1% of data labeled as bad quality. And the week before, we got 5%. So he or she sees that there's an improvement in the data quality provided for the data consumers. I think there's also a second thing we could use here. Because we're talking about labeled data here, we could perhaps infer more complex logic in the data when it is of bad quality. For example, we could train a machine learning model that detects more difficult patterns when data is wrong. We now had a really simple example with a total distance of 0 for a 2-hour drive with 50 kilometers an hour on average. That simply doesn't make sense. But in the real world, there are much more complex topics, and even perhaps things that are not that easily done by a data quality rule. So perhaps we could train a machine learning model to detect these errors, and perhaps even flag it as potentially incorrect, and then we get the labels back. We could compare it to each other. So it would be a nice idea to use machine learning for data quality. So hopefully that helps. Perhaps you have used something similar in your project. Please let me know, and thanks for your time. Goodbye.